So we've practiced already about writing our interval notations when it came to normal inequalities and then our compound inequalities. And remember, inside of our compound inequalities, we could either have our or statements or our and statements when they were graphed facing away from each other or facing towards each other. And this is now going into the next step. The whole purpose of having our interval notation is so that we can go ahead and describe the domain and range of pictures. So that's what we're going to focus on right now. So the instructions of your notes say, find the domain and range of each graph and write in its set notation and interval notation. Now remember, set notation is when you have an inequality. And then the interval notation, that is what we expect you to know inside of Algebra 2, and then of course if you go to college algebra. So what is domain and range? So let's pretend you've never seen it before. Domain is going to be our possible x values, and I like to think about this as being from left to right on the graph. So if you notice on our little heartbeat sort of shape, I have the leftmost point and I have the rightmost point, and they correspond with actual numbers on the x axis, okay? And so I drew these green lines right here so that we can see where they hit on the graph. I'm visual, so I like to have all these different colors that help me. So if I were doing my set notation, remember that's my inequality, then I would say, okay, well, this left-hand point is even, right? Because I drew my line straight down. It didn't slant it or anything. It just dropped straight down to the x-axis. It hits at a -6. And it has a closed dot, so I know I'm going to have a less than or equal to, and I'll fill in that equal to in a second. And then since I'm talking about the domain, I need to have an x variable here. And then I just include my rightmost point, which is going to be +6. And I'll include my equal to portion here. And so my set notation is going to be -6 is less than or equal to x, which is less than or equal to 6. So then when I write my interval notation, I can look at this and I can say, well, I have my set notation already, and we've already practiced this in our notes from the last time. So this is going to be -6 with a bracket, and then to a +6 with a bracket. So again, just one more time, I just want to show this to you. We had our leftmost point, which dropped down to -6. Remember, from our origin, it's -1, 2, 3, 4, 5, and 6. And then we start back over to find the rightmost point, which is 1, 2, 3, 4, 5, 6. Well, you might notice that I passed this point down here, and we actually ignore this for the domain because we don't really care about the bottom to the top, because that's actually our next part, which is the range. So if we change our color and we, let's say we have blue for range, this is going to be our possible y values, And so I like to think about this as from bottom to the top, because that is typically a good way to look at this when we're looking at our range on the y-axis, because the y-axis goes up and down. So if I look at my bottommost point is going to be right here, and it actually corresponds with 0, I can see. And then if I find the topmost point, and it's going to be less than or equal to, I am talking about the y-axis, so I am going to fill in my y really quickly. And then I look at my topmost point. My topmost point is going to be a +6, and it does in fact hit the 6, and it's a closed dot, so I can just put that equal to portion right there. And now I'm ready to write my interval notation. This should be same old bracket, 0, 6, and then a bracket. And we're just doing this over and over again for the next couple of pages. And we'll do most of them, but I will skip around a little bit. The answer key is going to be online for you on Google Classroom, though. So if you want to work on a couple of them, then you can, because obviously the more you practice, the better you get. But let's go to number 2. So this one is a similar, but we have a different picture, obviously. But we have our domain. Remember, this is from left, which looks like it hits at a -7, and it's a closed dot. So I'm going to say -7 is less than or equal to. Domain talks about x, so I include my x. And then I look at my rightmost point, which is an open dot, so that's not going to be a less than or equal to, it's just going to be a less than symbol, and that looks like it hits at the number 5. Somebody once asked me, well, is it important if you put the -7 first? Like, do you have to go from left to right? What if you switched your numbers and made it 5 and then -7? Well, then your answer would be wrong. Order matters greatly. You should always start with your smaller numbers and then go to your bigger numbers, which is why -7 has to come first, because it's smaller than 5. And then I write my interval notation. I have -7 with a closed dot, so it's going to be a bracket there. And then 5 is an open dot, so I'll have a parenthesis right there. Finally, we can do our range. And so I'm going to switch my color to blue. And it's going to be my bottommost point, which is going to be a -3, it looks like. And it is a closed dot, so I have that less than or equal to. And now again, we're talking about the y values. We're talking about along the y-axis. And so I'm going to include y here. And then I'm going to say it is less than, and it's an open dot, right? Because now I'm looking at the topmost point, and it seems to be even with 1. And then I can do my interval notation. So it should be -3 with a bracket, and then a 1 with a parenthesis. And so that is our domain and range. So let's move on. So number 4, we have a circle. A circle is symmetrical, not that that's super important for you to learn right now, but we can see pretty quickly that we're just going to be doing the same thing over and over again. If our circle is symmetrical on both sides, then it's pretty easy to see what our numbers are going to be. So we'll start from the leftmost point to the rightmost point. Our leftmost point looks like a -4, so it's going to be, just one more time, how I'm doing that is I'm starting at the origin and I'm going to the left, 1, 2, 3, 4, that's a -4, so I should have a -4, and then my rightmost point is 1, 2, 3, +4, all right, which makes sense because, again, a circle is symmetrical. So I'm going to say this is -4, and if you don't see a closed dot or an open dot, you should always assume it's a closed dot. So I'm going to say it's less than or equal to x, because domain is always about x, less than or equal to +4. Then our interval notation is just going to be a -4 with a bracket to a +4 with a bracket. And we do the same thing again with our range. Again, it's blue, and it's going to be from bottom to top. Again, I'm just counting from the origin. My bottommost number is -1, 2, 3, 4, -4, and my topmost is 1, 2, 3, 4, +4. All right, so I'll write that out. I'll say -4 is less than or equal to, because I don't see a dot, so I assume it's going to be a closed dot. I'm talking about my range, which is y, so it should be less than or equal to +4. Then we do our interval notation, -4 with a bracket to +4 with a bracket. All right, let's do number 5. Number 5 starts off the same. All right, so I can find my leftmost point pretty easily. It's right there on my origin. So my set notation, my inequality format is going to be from 0. But if you notice, I don't really have a rightmost point. Let me fill in the rest. It's going to be less than or equal to x. So on the right-hand side, I don't have like a specific number. It actually just has an arrowhead, which, as we discussed already, means that we go on forever in that particular direction. And if we're going on forever, I can't have an equal to symbol. So I'm just going to say it's less than, I don't know, some random number. I guess I could plug in an infinity. That actually doesn't make any sense. So I'm going to cross that out. And I'm only going to take the portion. Let me go ahead and circle this. I'm only going to take this portion right here, because obviously I don't want the other portion. It doesn't really make sense. I can't really plug in a number, if you will. I would have to plug in the concept of infinity, and that's something that we only really do in interval notation. So I'm just going to cross this out, and I'm going to rewrite that little portion I just circled off to the left. I'm going to rewrite it as x is greater than or equal to 0. And I made it greater than because if you go back, let me go back a little bit. If you go back, you can see that the mouth is facing the x. So when I finally write x is greater than, right, my mouth needs to face the variable still. So it's going to be greater than or equal to 0. And so this is really the only way we can write this set notation. Interval notation of this, we've done this before whenever we drew a graph. If you want to redraw a graph, we could do that. Here's a little graph, here's 0, we have a closed dot, and we are going to the right. And so we can draw our interval notation from here, but it should be bracket 0 to positive infinity, and infinity always has a parenthesis. So that is how we do our domain of number 5. Range is very, very similar. It's from bottom to top, which, funnily enough, is arrowheads for both of them. Yes, we do have that part in between, but again, range should always be from bottom to top, and we can see that we have arrowheads. So really, that's like negative infinity to positive infinity, or if I were doing my set notation, it'd be like, the concept of infinity is less than y, which is less than the concept of infinity, and really that doesn't really make any sense. So technically I could cross this out. Let me go ahead and do that. Oh, we don't need it. So how they like to write this in the set notation is they like to say all real numbers, because there could be any number that could be here, because it's the concept of infinity. You think about 10 being your highest number. Well, there's always one number after that, 11, and then a number after that, 12, etc. for infinity. Our interval notation, though, we can say is going to be negative infinity to positive infinity. So that is how we do this one. This is really common, so I would take special note number 5. Number 6. Number 6 is sort of meant to throw you off just a little bit, but hopefully it's not too bad. Our domain from left to right. All right, here's our leftmost point. It's an open dot on that 0. And then our rightmost point is an arrowhead, so infinity. So I'll say it's 0 is less than x. It does not have that equal to portion because it's an open dot. And it's less than infinity, not really something we write. So I'm going to cross that out, and I'm actually going to write it as x is greater than 0. So then I can write my interval notation. If you find it is better for you to draw out your picture, right? Because again, I'm visual. Here's the 0. We have an open dot going to the right, and then we can write our interval notation from this. So on the left-hand side, we have our 0, and it's in parenthesis because it's an open dot, to infinity, and then infinity always has a parenthesis. Our range is going to be a little different, though. So our range is going to be that bottom to top, and so we can see that our bottommost number is also our topmost number. So for our set notation, right, we can just write that since they're the same number, like they're equal to each other. So I'm going to say y, because it's range, y is equal to, and it looks like it is hitting at 4. 1, 2, 3, 4. Yep, it's hitting at 4. And there's not really anything else that I can do. To be honest, the interval notation, there really isn't anything I can do here, and which is an interesting thought. I'll say this is not applicable right now, but this is an interesting thought, because now we can sort of see that sometimes set notation is a lot more descriptive or helpful than our interval notation. Interval notation, if you will, can sort of be like an abbreviation of the set notation, but it's not all-encompassing. So set notation is also a really good skill to have, so I don't want you to think that one is superior to the other, if you will. But let's move on. So on the third page for you guys, I think we're going to start with number 7, because that is really helpful, and it's, again, very similar to that other concept we were just talking about. We have our domain from left to right, all right, and we can sort of see that our leftmost point is going to be at, 0, -1, -2, -3, and then our rightmost point is going to be 1, 2, 3, 4, and 5. Yep. And so I'm going to go ahead and write that. It's going to be an open dot to start off with. So -3 is less than x, because that's what we're talking about, which is less than or equal to +5. And so when I write my interval notation, it's going to be parenthesis around the -3 and a bracket around the 5. Our range, again, it doesn't have a bottom to the top because they happen to be the same number. They're equal to each other. So I'm going to say y is equal to, and it hits the y-axis at 1. So it'd be y equals, or something, not +1, but -1. It hits at -1. So I'll say the range is y equals -1. And because there is no interval notation for this, at least not that I know of, we're going to say it is not applicable. So I think you guys can figure out the others on this page, so we're actually going to skip over to the last page. So here we have number 10 through 12. Number 10 is, again, very similar to what we've done before. It should be pretty straightforward with our left to right for the domain and our bottom to the top for our range. So let's do number 11 to start off with. So we're going to start off with our domain, which is from left to right. And notice, once again, we have arrowheads, right? So if we were doing our set notation, it'd be like infinity, which is less than x, which is less than infinity. And that's weird. So we're just going to say it's all real numbers, because We're not plugging in infinity on the inequality like that. That's just not a thing. But we are allowed to plug it into our interval notation. So we would say this is from negative infinity to positive infinity. And again, we have the parentheses around infinity because that is always the grouping symbols that need to be used for that concept. Our range, however, we do have a bottommost point. It actually hits here at 0 on the y-axis, but our, well, topmost point is going to be that infinity concept again. So I'm going to say my set notation is going to be from 0, which is less than or equal to, and I know it has the equal to because I don't see an open dot. So it's assumed. I know they always tell you not to assume things, but there's some things you can assume when it comes to mathematics, and this is one of them. So 0 is less than or equal to y, which is less than infinity. Yeah, that's a little weird. So we're just going to cross out this little portion, and I'm going to rewrite it. Y is greater than or equal to 0. And our interval notation, again, if you want to draw this concept, you can. Here's our number line with 0. We have a closed dot, and it's going to the right. So we can draw our interval notation from that, and it's going to be bracket 0 to positive infinity with a parenthesis. All right, last one, number 12. So we have our domain from left to right. Well, dang it, look at that. We have our infinity concepts again, our arrows. That means they go on forever. So again, when I do my set notation, it's from infinity to infinity, which is what we write as all real numbers. And our interval notation is in fact from negative infinity to positive infinity. And then we finally come to our range, which I'm going to change the color to blue again, and I'm going to get our, well, yep, there it is again. From bottom to top, we again have our arrows, and so we're going to have the exact same range as we do with our domain. It's that concept of infinity, which is less than y, which is less than infinity, but we can't put that inside of our set notation, so we write all real numbers, something like that. I can spell, it's fine. And then interval notation is going to be from negative infinity to positive infinity. So I hope that was helpful. The homework is basically the same thing. So I'm going to show you what that looks like. So if you go to Google Classroom, I have a lot of stuff in here for you, but you can click on your classwork assignments, and you can find the entire section about interval notation, which is really, really short, right there at the very top for you. So we have this interval notation, and you guys care about the graphs and interval notation. This is what you guys care about. And I posted this a while ago, but if you open that up, you'll actually come to a lot of information right here. So, and I tried to be pretty clear about what you need to do, but here are the blank notes, here are the filled in notes. So if you want to do that extra practice, the problems we did not do in the video, then you can obviously come here and check your answers. And then here's your homework. It's a domain and range from a graph puzzle. So I'm just going to show you what that looks like, since you might have questions. But this is what it looks like, and it tells you pretty much what you need to do. They say that the first one you should start off with is E, right? And so let's just put it right here. So this particular tile, you're going to click and you're going to drag it right in this position. And along the side, you can sort of see your range and your domain. And so you want to organize all of these so that your domain and range match according to E. So I have, it's a little hard to see, but I have a domain from here. This is from left to right, 0 to 1, 2, 3. So from 0 to 3 is my domain, and then my range would be, well, I'll let you guys figure that one out. But you want to find your domain that matches what I just said, from 0 to 1, 2, 3. Yeah, that looks right. 1, 2, 3. Yep. It's really hard to count on here. Anyway, so you want to find from 0 to 3, and you want to put that underneath, because the word domain is underneath. So like this one could match. I don't know if it does, but it could. So I have 0 to 3, and I would maybe want to put this E right there, and maybe I underneath it, so that the domain matches this domain, if that makes sense. If you have any questions, just let me know and remind, and I'd be more than happy to help you. Good luck.